who are proposed. Hello, sir.
But
Am I audible?
why not
Sir.
why not we call also
Sir.
MS Prasad and Shivani and also our MK Datta.
Okay. I'm sending the invitation to them as well, sir.
Oh.
Today we will be interacting with two participants. One is Dr. Rika Sharma from Chhattisgarh campus and another one is Dr. Abul Amir Khan from Haryana campus, sir.
Right.
We have proposed their names in data analytics session 2, sir. Sir, are you calling MS Prasad, sir?
Yes, Shifar. I'm trying.
Sharing. Okay, sir.
Now, let us keep him in the loop for all the presentations.
Okay, sir.
He has really, he knows the subject very well.
Sure, sir.
Good afternoon, Prasad. Are you in the office? Okay. Can you just join us online in that there are two presentations yesterday we couldn't make, now one from Haryana, one from just join. Shefali is sending the link just now. Abhi join kar le, because I need your input also. And Shivani also can join.
Sir, I have shared the link, sir.
He will join. Dr. Datta, good afternoon. Shefali,
Sir.
Please send it to Datta also, he will join.
Done, sir.
So now you can go ahead.
Sir, we have been joined by Dr. Rika Sharma from Chhattisgarh and Dr. Abul Amir Khan from Haryana campus. And we have proposed their names in data analytics part, session 2, sir.
Right. Prasad, thank you. And Shivani, thank you for joining.
Good afternoon, sir. Thank you so much for joining, sir. Thank you so much. Sir, shall we start with Dr. Rika Sharma?
Prasad Saab.
Dr. Rika, please upload your presentation.
He is the topmost expert, Prasad.
Yeah.
In space means I only look at him as my own guru also. Space research.
It is not that, sir. That ROV meeting went on very nice, sir.
Well, how was the deliberation? Now you should get that project, ROV.
We are dividing it into two parts. Hardware, somebody else, and entire software, perhaps our team would be doing it.
Achha. Because hardware will be the engineering part which will take the bomb to the deep waters.
Yes, sir.
So you will write the software part of it.
That hardware is being made by Kochi company for other departments. I have to simply modify it a little bit.
They have already done that, isn't it? This company.
Yes.
Sir, Dr. Khatri has also joined, sir.
Right. Khatri sir, namaskar. So Rika, now you can start your presentation.
Good afternoon, sir.
All the best.
Yes, sir. Good afternoon, sir.
Good afternoon. You were there yesterday, so we had given some guidelines. Please follow that. Best wishes. Go ahead. Dr. Rika, you can start.
I think there is some network problem, sir. Dr. Abul? Sir, if you permit, can we start with Dr. Abul?
Yes, please.
Meanwhile, I'm contacting Dr. Rika also. Dr. Abul, please upload your presentation.
Okay.
Dr. Abul Amir
Thank you.
Khan, best wishes. We couldn't hear you yesterday, and good luck. We want to listen to you.
So I have shared the screen. Is it visible?
Yes, please.
Yes.
Okay. So
But show it in full screen. Huh?
Yeah.
That's right.
So good afternoon, one and all, and thank you very much for the consideration. My name is Dr. Abul Amir Khan. I am assistant professor in Amity University, Haryana. I am serving in ACOS, that is Amity Center for Ocean Atmospheric Science and Technology. So as I tried to make the presentation according to the format Dr. Shefali has shared. So this is about my detail. My research area is basically glaciology, stable isotopes, groundwater chemistry, atmosphere, cryosphere interaction, and on the right hand side are some of my publications in a high impact journal, which is based on oxygen isotopes, glaciology, and atmospheric science.
You use the remote sensing data and images for this your papers.
Yeah,
What was
one of them. The second one, the cryosphere a precipitation perspective of the hydrosphere cryosphere interaction, in which I have used the TRMM tropical rainfall measuring missions for 10 years data and try to validate the remote sensing data, TRMM data, with the available rain gauge data and also the Aphrodite data. So yes, in that I have done some remote sensing work.
Because in the delegation from ISRO, from Hyderabad, there is a national remote sensing center. There are 6 people coming only from there. So that is why, I want to understand that where do you get this data and images? Is it IRS pictures, images you get, or where did you access this? Are open source?
Yeah, so this is TRMM data, tropical rainfall measuring missions. I have used the precipitation data, rainfall data over whole Indian region, and I tried to validate the satellite data with the available rain gauge data. So yes, now the TRMM has been closed. It has been modified with GNP, Global Network Measurement Mission. So yeah, this I published in long back, 7-8 years back. Yes, but I use the remote sensing data as you are asking. So I would like to understand about the Mars climate, which I have discussed 2 days back. So one of the most suitable locations to compare the Martian terrain on Earth is Ladakh. We know that, and a lot of scientists are working on that. And within Ladakh, there are 2 regions, Sokar Basin and Puga Hot Springs, which are ideal analogs of the Mars. And we all know Ladakh is located in high altitude region, more than 3,000 to more than 5,500 meters. There are some similarities between Ladakh and particularly in that region, which I have mentioned, and in Mars. So a few of them are, they both region have low temperature and low atmospheric pressure. They both have oxygen deficient environment. There is a frequent occurrence of dust storms, which we observed in Ladakh, and we also know in Mars. Higher solar radiations, there are some features, some geographical or you can say geomorphological features like gullies on Mars, which resembles water carved channels on Earth. So there I have tried to compile few similarities between in these two environments. So by studying these sites can be used to question about the origin and evolution of life, habitability and biosignature. And the most important thing, in addition to the ground truthing of the several instruments that to be used at these off Earth locations. So whatever remote sensing data we are using and getting the information from over the Mars, we can use Ladakh as a for a ground truthing. Ground truthing is always important when we are using remote sensing data. So this is some of the images. The first one is the detects about the liquid water lake beneath the Martian landscape. And we all know that the future of human exploration of Mars is largely dependent on the availability of water. Mars is now cold, barren, and dry, while earlier it was believed it is warm and deep wet. The planet Mars has a home to ample liquid water and lakes long back 3.6 billion years. The arid region of Ladakh covers a large extent of debris-covered glaciers and buried permafrost, which can be well compared with the Martian terrain. Topographical evidence also suggests that it might have been resemblance to present-day Ladakh. Some of the features which we remote sensing data which we are getting from the Mars, there are several data available which suggest a lot of similarity between the Mars and the Ladakh. So these are some of the field photographs which I'm showing for this on the left hand side. This is the Sokal Lake which I am mentioning very frequently, and this is the Puga hot spring, and we can see a salt, a huge amount of salt, and this lake is evaporating very fast. And we observed over my stay of more than a month or so, I observed a frequent occurrence of dust storms, and the salt is blowing here and there. So, and we also, as I showed you in my previous slide, we have evidence over the salt deposits, salt kind of small mountains over the Mars, which I believe that in very fast we can observe in this region. And on the right hand side, I have also done an expedition in 2019 with Delhi University, Haryana, in which I used the atmospheric observation started from the Panchgaon, and then from a different location I stopped and I have measured the sun photometer. This is the portable instrument which give us AOD, which is nothing but the aerosol optical depth, which is a indirect measurement of about the pollutant. So as I can see, when we covered this region, Ladakh region, Dras and the Leh, it is very low, 0.19 and 0.21. So simple, the lower value suggests that there is a because it is, I have used 500 nanometer wavelength. So the lower value suggests the existence of coarser particles, and the higher value suggests the existence of finer particles. And finer particles are mostly attributed to anthropogenic activities, and the coarser particles of the low value suggest the natural phenomena like dust and other things. So overall, I would like to understand the climate of Mars by studying the climate of Ladakh, by using the remote sensing technology, by using the geomorphological features and subsurface also, like permafrost region, which we have observed in a Sokar Lake by ground penetrating radar. This is also a kind of remote sense data and direct information about the subsurface. And Mars Advanced Radar for Subsurface and Ionosphere Sounding, which is also known as MARSIS data from the Mars Express orbiter, had suggested the existence of 3 to 4 buried reservoirs of salty water near the south pole of Mars. And then, as I said, I would also use these sites as a ground truthing of similar features on Mars. The third, definitely these are the possible works. I can focus 1 or 2 or 3 according what you guys जैसा आप लोग suggest करेंगे. So hypersaline nature of Sokal Lake by chemical and isotopic studies, I would like to understand. So contrary to the evaporation of sea or ocean water, the rate of evaporation for such hypersaline lakes at high altitude is directly proportional to the dryness in the atmosphere. As I told you, this Sokal Lake is evaporating very fast, and this is an indication of the dryness of the atmosphere, particularly in Ladakh. And we have also evidence of the past lakes and the paleo lakes over the Mars. And second is atmospheric process. Because this is my expertise, I can add the atmospheric process, rain soil chemistry. And the most important thing, which I am not sure that it is doable, but if we can did that, then this will be a great contribution, which is the ice core samples or the core samples, which will definitely understand about the past climate. So this is my penultimate slide. I will take hardly 5 minutes, but this is very important to understand that how oxygen isotopes can be used as a proxy. So we know that oxygen has a 3 stable isotopes, O16, O17, and O18. The existence O16 is the highest abundance. As you can see, 99.76% is the abundance of O16, and which is a lighter isotope. And the abundance of O18 is very less. You can see 0.20. So these oxygen isotopes are evaporated, or you can say fractionated during evaporation and condensation. O18 is heavier and O16 is lighter. So they behave differently during evaporation as well as during condensation. So this is the formula which we use for the oxygen isotopes, which is DAL18O is equal to O18 by O16 of sample in which we are collecting. It could be river, it could be lake, it could be rain. And then O18 by O16 ratio of standard divided by O18 by O16 ratio of standard. The standard we frequently used here is VSMOW, which stands for Vienna Standard Mean Ocean Water. So we always compared with that. And then at the end, we multiplied by 1000 so that we cannot get very smaller value like 0.000 something. To avoid that, we multiplied by this ratio. And one important thing is that if we are getting okay, this is the cartoon diagram which shows how oxygen isotopes actually fractionate in the atmosphere. So on the left hand side is the ocean, and on the right hand side this can consider the mountains. So as I told you, the abundance of O16 is very high, more than 99%, and they are lighter. So during evaporation, since they are lighter, they evaporate preferentially than O18. It doesn't mean that O18 is not incorporating into the water vapor, but preferentially. So O16 evaporates preferentially than O18 in the water vapor. And these are the isotopic signature of water vapor. So when the clouds form and then the precipitation starts, so the initial precipitation, whatever O18 is in the clouds, they fall first because they are heavy. So they fall first. When the clouds mass move towards the mountains, or in this diagram, you can consider the Himalaya also. So with subsequent precipitation, since O18 is heavy, it falls earlier. And the remaining water vapor of the cloud will be enriched in O16. So let us assume on the right, the extreme right, the final precipitation, you can say when it is fall, it will be enriched in O16. So this will be O16, the value of O16 will be very low, or you can say negative value, most negative value compared to the ocean. So when these snow forms and then fall over the this snowfall becomes ice and glacier in the subsequent time, they may have different signatures. Now one more thing, we can understand this in a longer term also. When there is, let us say, warmer period, then more evaporation, and then O6, whatever O16 is locked in the ice, that will start melting. And during glacial period, there's an evaporation, the ice is locked in the O16 will be locked in the ice, and it is not melting because of low temperature. So they have different signature. So during this glacier and interglacial cycles, we will get the ice cores. Then we can tell us about the past climate, what happened in the past, and we can also calculate or estimate the past temperature of that time by using that isotopes. So this is all from my side.
Thank you, Dr. Abul. Now, Prasad, are you there? Prasad?
Yeah, I would like to, Dr. Abdul.
Yes.
Can you hear me, Abul?
Yes, I can hear you.
There are a couple of things I will tell you. You see, whatever study you have done, generally what happens, are you getting the Martian image from Perseverance? Are you getting some data from Mars Perseverance image rover?
I searched at the internet, and whatever information, as I showed you 2 pictures, this is what I.
That's all. No. I will check up. I will talk to Sarvamurthy sir. I have the large number of data available, but I do not know I can share it with others or not because I am a member of some organization. So see, the major thrust is that ISRO, if he gives you the image or some ionospheric measurement, how you are going to use it. See, the oxygen isotope and Vienna, ocean level consideration came because oxygen isotope is used for nuclear purposes, for cleaning the isotopes, and bringing it to nuclear material. So we need not bring this, we bring it to the fact that when the NRSA gives the image, or ISRO gives the image, or Aditya L1 gives me the data, or some ionospheric image if what a study I can do. And I can just, sir is there, I have been a mountaineer. Ladakh is easily available. That's why people say it looks like Mars. There are Karakoram passes, where they all look like, Mars only. Only thing is, Ladakh, you can go by air and travel. It's not so. Similar, Helsinki in Canada looks like Martian surface.
Right.
And you please see the perseverance photograph. I will talk to sir and try and get you some information. So please make the PPT like that, and then we can conclude how to do it.
Thank you, Prasad. Dr. Datta? Dr. M.K. Datta?
Now,
I
he
think,
may not do this.
I think, sir, I do not have any experience with.
That.
Okay, ठीक है. Dr. A.K. Singh, please.
Sir, I have 2-3 submissions. One is, if we really see the first, he has explained it nicely, and I appreciate the changes he has made. But थोड़ा सा, I think, थोड़ा सा science ज़्यादा हो गया उसको. I think he can always, curtail it, because this Abul, what role do we have in that place in Ladakh? You say Amity Center. Do we have any center there?
Actually, it was started long back. Dr. Siddharth initiated and our Chancellor sir has also initiated that, but it could not be materialized. He got
No. What I'm saying, what kind of exclusivity we have there? Means, how can we say that it is our center or we are participating? Because my next submission is based on this.
Yeah, so yeah, I mean, it was started by, it was the initiation was taken by Amity University Mumbai. The objective was same, to understand that environment for better understanding over the Mars. So in which we advertise that, and not only Indians, some scientists from Australia was there and they have participated. So some expertise in geology, some have expertise in
Okay, now, what I feel, Dr. Selmurthy sir, I have, the area which he is talking does not fall into the data analytics. It basically falls into the astrobiology.
Yes.
And since we have only one presentation by VC or his rep, I think he should be talking in astrobiology, one. Number two, I think we should, I recommend that we should include him, because he is talking something different. Because now Dr. Prasad has also raised the point that this is the easiest approachable, akin to Martian or Mars surface. That's why we are talking. But certainly this will give us some edge that we can do some studies in astrobiology for times to come. Because ultimately ISRO is also moving to the man missions, because their futuristic missions would be linked to the life. So if our study can add on in understanding and knowledge, so I think if he can just change his presentation. He said that he would like to study the climate at Mars. That
Yes.
could be one specific problem. But would you mind enhancing the scope of your presentation by saying that your expertise and at that place you can study more if they want, and showcase your strength, that you can do some substantial work in times to come. That's what I feel.
Thank you, Dr. A.K. I think very right decisions. I'll just answer some of them which he couldn't answer. See, the first thing is Amity University Mumbai was trying to lease out some land in Ladakh and to designate that as our center. I think this we can clarify, because this was actually under possession of Amity University Mumbai. Siddharth Pandey went several times to talk to the local authorities, because you cannot purchase a land. But they were leasing out that part, maybe 1 acre or something around that place, for this purpose, and calling it as a Mars analog station of Amity University Mumbai.
Right.
And then they conducted these expeditions, where Australian team came, NASA people came, European agencies, they all came there. They made a camp and made some studies there. Particularly, they collected the microbes who are existing in the subterranean microbial consortium growing in that, whether it can be analogous to even those which may be there in Mars environment. So they were collecting those psychrophilic bacteria and other microbes from the samples. This much I know, but we will get
Extremophiles.
correct, extremophiles.
Not
Not Correct, extremophiles. So they were doing experiment. They have published some papers also. Amity University Mumbai has published. So your wise advice will be that we can show that, see, once the Amity University Mumbai finishes the presentation, they will mention Mars Analog Station. So immediately we'll bring you there. That's I was also thinking in the same line which you have actually mentioned. So we will bring there, and there you can mention about how you can study the living conditions there, oxygen, and also the water which is required, how it will evaporate, how the snow, if it is below that permafrost, like this, if there are permafrost underneath, we get water from there. So a lot of things can be seen if there has to be a habitability in for which your data. So you should relate it to their interest, not that what you have done, so that it should be like a story. After he finishes, immediately we will request you to speak. Amir, can you just mention about your atmospheric data and also living the life parameters which are required to be there in the meteorology and in the terrains as well as in the living conditions. So like that, then you can come on. Yes, that's a good suggestion, AK. Now, Neeraj Sharma ji, can we have your thoughts, please?
I think, sir, he has changed a little bit last time and this time comparatively. It is a better presentation, better subject
Yes.
that he has chosen. So it is a good thing that he has understood what we wanted from this entire exercise. And I believe that ISRO is also, I think, reactivating the Mars mission. I think once again they are working on it. I've read it somewhere that they are now working on it, sending some kind of a helicopter, a small helicopter over there, or maybe rover or something of that kind is happening. So I think if we only suggestion is that Abul can study those kinds of things and correlate with the ISRO missions, future missions for Mars. That's it, sir.
This is a very good suggestion, Neeraj ji. Abdul,
Yes, sir.
Abdul,
Yeah.
see, what he wants is already some studies of the atmospheric conditions in Mars using the orbiter, Mars orbiter, as well as the helicopter for land hopping from one place to the other, monitoring the atmospheric terrain conditions, water. They are already doing some experiments there from other space mission, not Indian.
NASA, yeah.
NASA has done that. So if you can look at all the informations available, then you can even relate. Mars has done these experiments. So some data are available, and then maybe when our own orbiter mission, they are also looking for certain things like this. So our Indian, you have to find that is there any reference which you can bring in relevance to what you are presenting from Indian Mars orbiter mission as well as from the other missions. Then you can relate, they have done this, Chinese, if they have done anything on this area, bring that. Then now, based on this we can do from our side. Like that you should bring.
Dr. Abul,
Yeah.
do you have expertise of differentially measuring O18 and O16?
I do not have, but I know the science. I mean, what is the principle behind it? It is isotope stable isotope ratio IRMS, isotopic ratio mass spectrometer, which is not available here. But yes, that instrument measure the O18 by O16 ratio. So
both O18, what are the emissions of O18 and O16?
Sorry, what are the emissions?
Emission difference.
As I told you, when we are talking about the Earth, one more thing, these are oxygen isotopes data are also available for the Mars. I have gone through from the data the NASA has done. They have collected the atmospheric samples and then they have measured these isotopes. So they found in Mars atmosphere, O18 concentration is very high. O16 is about to finish. And they said O16 goes to the space. Their water vapor is increased in O18. In our case, currently in our Earth, we have more O16.
One more thing, when they evaporate, it means if you really go into the micro analysis, the O18 layer would be lower towards the gravity than O16. Can I say that there would be a layer enriched in O16 and lower layer would be enriched in O18? I don't know. Chalo, we are going up a bit digressing.
Yeah.
That's
So,
all what I
first
want.
of
Yeah,
all,
okay.
they do not
Anything
like,
else
they do
there?
not form, because H2O, I'm talking about the water. So they exist in
H2O.
the form of water. It is not like
H2O.
so they exist in form that either could
Thank
be
you.
increased, it could be depleted, but there is no different kind of layers they can form. And I also started thinking the gravity is different. Mars, the gravity at 3.4 or something, and at the Earth we have very high. So that could, it could be the reason that might be 16 goes out. But then I in the literature they said that there is no relation of evaporation precipitation on gravity. Gravity cannot affect much on that.
Dr. Khatri?
Yes, Dr. Abul, it was a very wonderful presentation highlighting all the possibilities, that research areas that you can work on. But I would request if you can focus and highlight on what you would like to do with the help of ISRO and how you can primarily focus on contributing towards the ISRO. So if you can just reshape the language of those 3, 4 slides, that will be much better for them and give a clarity that what you would like to do with them and how you would like to contribute.
Thank you.
Dr. Datta, anything else you want to add, Datta? Okay, thank you. Thank you. So, Abdul is very clear now. Look into literature first to relate the significance for space research and also bring relevance to Indian space research, so that in the background of global picture. So that is the only major suggestion for you. And we will bring you in the last session, astrobiology, in which after Mumbai presentation, that we will have you, whether you will be coming online or offline, that we'll now take the approval from founder president. Now, can we go to Dr. Rika Sharma, please?
Dr. Rika, please make it slideshow.
Yeah.
And if possible, please turn on your camera. Rika, title. Dr. Abul, meanwhile, please share your title of the presentation also.
Okay.
Thank you so much.
Yes, ma'am, it's visible.
Yes, Rika, please go ahead.
Good afternoon, Honorable Chancellor, sir. Good afternoon to the respected esteemed members. I apologize for yesterday. I was not able to connect because of some network issue. I was traveling. So, shall I continue?
Yeah, please.
I'm presenting the data-driven anomaly detection for space exploration. So I have chosen the topic that is anomaly detection because it plays an important role. As we can see from here that the satellite data that is generated is generally a spatio-temporal data, and it is space as well as time plays an important role in any scientific data. So spacecraft missions involve complicated spatio-temporal dynamic operations, and it requires continued real-time monitoring of spacecraft status and health to ensure mission success. So here the health and the status of the spacecraft plays an important role, and anomaly detection can help us to identify the status and health of the spacecraft. So this is one of the objective of anomaly detection in space mission. Detecting anomalies in a spacecraft remote sensing data is a critical task for engineers so that it can identify the unexpected or abnormal behavior, and based on that, necessary corrective measures can be taken. The challenge that is faced for this type of anomaly detection in this remote sensing high dimensional data is a high dimensional non-linearity, non-stationary nature of spacecraft remote sensing data, and more advanced data analytics and machine learning techniques is required for this anomaly detection. So just first I will go through that what is actually anomaly detection is. So from here we can see that here we have a satellite image, and in this image there is some region of interest that shows some behavior that is not a uniform, or that is not a standard behavior, that is unexpected, some behavior is there. So we have a concept of outlier or anomaly. Outlier is the irrelevant data that is of not of significance, but anomaly is the unexpected data pattern that is relevant for the any scientific discovery or anything that can be discovered with the help of those anomalies. So here we can see that this is the general trend of the time series, but these two shows the anomalies. That is, this two behavior needs to be identified, because when there is uniform time series we are getting, that shows the normal event. But when there is any abnormality in the in any time series generation, then we can that is area of interest, that is region of interest, which has to be explored further to identify if it reveals some significant pattern in from the data or from any event. So here the methods that is adopted for this anomaly detection is that data collection is done. For that, data is to be acquired, some feature extraction, doing pre-processing, feature engineering, and multimodal data fusion. That is data is fused from various sources of data. Then anomaly detection is done. It can be graph based, that reveals the relationship between the different features of the data set. Then we have online learning and adaptation is there, in which based on the change in the data, the algorithm will be able to learn and predict the any anomaly from the data insights. Then dynamic thresholding and alerting is because there is no any standard method to find out the anomaly detection. For data-driven anomaly detection, we have to get deeper insights of the data, so that model can learn from the data and can be trained to get the anomalous pattern from those data, and based on that anomalous pattern, some decision making tasks can be performed. So decision making and response. So based on the anomaly detection, some corrective measurements can be done, prioritization and alerting. The alert can be sent by either through the notification, and explanation, action and decision is to be taken based on the anomaly, so that before something abruptive can happen, we can avoid that from the particular data insights. So these are some of the data-driven algorithm that is generally used, that is a statistical model and machine learning algorithm to get the abnormal behavior from the data. And statistical model uses linear regression, some of the time series analysis, and machine learning algorithm we uses this method, that is regression tree, support vector regression, artificial neural network, deep learning, ensemble methods. So these all data-driven algorithms we can use to find the anomalous pattern. This is one of the study from my area of research, because I have done my research in the NASA data, specifically to the ocean data that studies about the SST, that is sea surface temperature, sea level pressure. Then oceanic Nino index I have studied, in which we find which we try to find out the some abnormal pattern behavior that reveals some useful pattern, useful events from those data. So here we can see that this peak events which are showing, and this has been identified from this algorithm that has been proposed during my research work. I have proposed this change detection algorithm. So this change that is that is shown as a peak values, this change is the area of interest. In this change, we try to relate it with the event that has actually happened. So here we can see that all those events that is showing through this change detection algorithm that has been displayed here, it reveals that those years were either this red shows that it was El Nino years, and this blue shows in which the temperature was down. It shows the La Nina years, in which flood it is announced as a flood years, and during El Nino drought happens. So this is the data-driven change detection algorithm that we have proposed during our research work. And when we find out the accuracy and the other performance parameters for this, we got the exact phenomena that that has already happened. So it was able to do the predictive analytics based on this algorithm. So this is a space science spatiotemporal data. So as a space science now, this particular anomaly detection, how it will help in the space mission. So as a space mission grows more complex, data analytic definitely plays a very important role. This particular data analytics is needed for precise navigation and landing because it will help us to identify the trajectory and as well as the specific time and the space where it will help us that will help us to do the landing of the any space. Data from different sensors on the lander and the orbiter will help to make smart choices during the mission. It helps in decision making such as the right turn. So these are the applications where this anomaly detection can be helpful, avoid problems and use fuel efficiently. It will help us to predict the landing spots, lunar soil analysis, mission planning. This is one of the example where anomaly recovery, this was the mission Curiosity Perseverance rovers. In Curiosity, it collects the data samples from on-site using the rovers, and in Perseverance, it collects the rock cores so that it can be studied for future advanced study by the scientist. So this is the anomaly recovery can help for the better performance of the better performance in the space mission. These are the areas where we can explore that is some of the anomaly detection methods that exist, that is called as traditional way of anomaly detection, graphical approach, some statistical approach, machine learning, density approach, and time series methods. So this approach is a traditional approach, but with the advancement of the technology and with a lot of data being generated, we are moving from this statistical based approach to the data analytics and the machine learning and deep neural network model. So for this, these are the proposed areas of research in which spacecraft diagnostic can be done to identify the potential issues during the mission so that anything happens before it can be countermeasured. Next one is the astrophysical observation that will help to identify the unexpected pattern. And unexpected pattern, it was always not anomalous because it is a region of interest. It may happen that it can lead to discovery of some new phenomena. Planetary science data such as rovers and orbiters, it detect changes in surface features or atmospheric composition.
Can you hear me, Rika?
Yes, sir.
It looks like a textbook thing you are showing. It is hard to identify the problem because it looks like a textbook of space science. So the end-to-end problems are missing. So I'm not able to, like, most likely you have to restructure a few things.
That's how
Like, if you look into this, there's some text stuff. Looks like text.
Rika, Dr.
Yes, sir.
Rika,
Yes, sir. Yes, sir.
Rika, is it your PhD thesis?
Sir, this work is from my PhD thesis, this one. And based on that, I have
Rika,
tried to
let
relate
me
it with the
explain you.
space mission.
You have done a good work,
Let
but
me,
then you
let me
see,
finish. Actually,
you
Rika,
have,
the point
yes,
is,
you have mixed up the so many things. Anomaly detection, outlier detections are two different things.
so इनको finish करने दीजिए. Let her finish the slides, Rika. अब slides finish कर लीजिए. लेकिन क्या है कि it looks very textbook data. You know, it is not looking like a post problem. If you finish, अब एक बार जल्दी उसको finish करिए, फिर प्रसाद sir will tell you. Maybe I have some input.
Yes, Rika, I will take your number and I will talk to you how to make it good. Okay. Otherwise, it is more of a theory and it does not connect to the problem today.
मतलब Rika, आपके पास adequate content है. It has to be aligned to look like a promising problem. I think you have
Yes,
enough.
sir. Yes, sir. Sir, just give me time. But sir, because I just tried to relate it with my work, so I have not been able to get it to the sort of presentation. Definitely, I will improve it. But just for now, it is the points that I will like to focus. But definitely this will not be the presentation. It is just
Because,
for
you see,
explaining
Rika,
that.
Rika, 1 minute.
Rika, the point is, if we show all the basic science, basic space science to those the ISRO people, they will not like it because these are textbook things. So we can
Correct.
align it as a problem and make it interesting, and you have adequate experience also. Rika, you quickly finish the slides, then maybe we'll come back.
Yes, sir. Yes, sir.
This is the last one, I think.
Yes, sir. So these are some of the problems which can be, these are the proposed areas of research, and these are the methods because specifically to mention some any algorithms, I have to go through the literature review. So these are the advanced techniques that are now being used. I have studied some of the papers. So from that, I have identified that real-time monitoring and alerts, this is the interest of area where continuously monitor and track data is required for anomaly occurrence, which can be critical for space missions such as unexpected temperature changes that has to be identified, power fluctuation, and unusual movement patterns. So these are some of the areas and advanced data analytics and machine learning model is being used for this. And for the specifically mentioning the techniques and the algorithms, I have to go through some more literature review. Then only I will be able to identify and pinpoint the model and the algorithms. And these are some of the research work in particularly in this specific domain. It is related with the scientific data. So this is all about.
Rika, we have a faculty. Sir, can I explain her?
Please,
Rika,
please.
are you there?
Please
Yes,
go
sir.
ahead.
Yes, sir.
Can you hear us?
Yes, sir.
Okay, okay. Rika, Dr. Rika, two things. You know, you have to align your talk regarding a space. And we have a faculty here who is talking on anomaly detection for a cognizant health analysis of a spaceship. We will try and incorporate your couple of slides inside that so that it makes much better sense. But see, what you are listing is more or less, just theoretical aspect. Anomaly detection per se is a little complex problem. It is not just finding out little this thing, because you see in the spacecraft you have 20 sensors. 20 sensors give you different type of data. Then the question comes, what type of anomaly it is, how it should be repaired. Those are the couple of problems which is access. It is not only power and the budget. Okay, so no problem. I will get in touch with you by tomorrow. I will take your number from Shivali and talk to you. Okay, good.
Right. Dr. Datta?
Yes, sir.
I have some quick observations, Rika. The point is, you see, AI is changing very fast. So if you say 4 generations of AI, machine learning is first generation, deep learning is second generation, then comes generative AI, third generation, and the current generation we're in transformers, right? So many terms in your PPT are from the first generation, like you're showing support vector machine. That may not go very well. We understand that you have done work on support vector machine, but because we will be dealing with the voluminous data, so machine learning models may not make too much sense. No? Let us say if we have got good amount of data, we can use transformers, we can use deep neural networks, and also if we show support vector machines or some basic machine learning model, it doesn't go well. I mean, 2010 these things are finished. Now we are in so little bit let the problem be same. Instead of writing support vector machine, you propose you will use a more advanced method, let's say deep neural network or a transformer architecture or a sequential modeling. Use those kind of words. I think avoid some some, let's say 2010 time machine learning model like support vector machine. I think that, and because we are proposing a problem, so when we propose, we will say that we have done in, if they ask you, you can tell I have done in machine learning models, but my proposal is on, I'll be using advanced models like transformers or sequential modeling, or so. Otherwise, I think your idea is very nice. Maybe a little bit of alignment, and I think very nice. We just need to little bit align.
Actually, sir, just 1 minute, sir. This support vector machine and these algorithms I have not used, but it is just for the reference that these are the literature work that has been done. because we have proposed the data-driven algorithms. Because as data is not the supervised data, so this is unsupervised data. So to get the deeper insights of the data, we have proposed the data-driven algorithms based on the study of different statistical models we have applied on. Based on that, we have proposed some algorithms. So change detection algorithms we have proposed. We have not used the traditional models. I have used neural network concepts to identify the anomalies, just like self-organizing map.
Don't keep those words in the slide. I think you better remove those words. That will unnecessary confusion.
Yes,
Use some.
yes, sir. Yes, sir. Sure.
That's it.
Yes, sir.
My
Sure, sir.
summary points are: use some advanced methods of use some advanced technical terms and align your problem. Many of your slides are looking very textbook stuff. Otherwise, it is very nice.
Ajay,
Yes,
Ajay,
sure.
Sir, I think she has made a good presentation. But what I find that it was more of kind of a teaching exercise. But you have to see, because what you are proposing, how you differentiate with them, means in what way you would be adding to their present knowledge, either on x-axis or y-axis, means something better or something otherwise or alternative, so that the acceptability of our proposal is more, means they feel that yes, we can do some value addition. That is my worry. Otherwise, good, this is
Yeah.
a very useful
that
area.
Neeraj?
Yes, sir. Sure.
Sir, speaking in the last has its own challenges because everything is spoken. Now, having said that, I will also say that she has to define the problem very clearly. I think the problem is not defined here, as far as I understand. And how much ISRO will be interested in this kind of an exercise. And secondly, if such things are already happening somewhere in some form, are we doing something new, something extra? That is what she has to bring out. The role of ISRO in this, she has to bring out very clearly. Otherwise, the topic is good, topic is fine, but she has to define it properly.
Correct, correct. That's Sunil.
Yes, sir. Dr. Rika, very wonderful topic,
Yes.
and definitely it would be of interest for us and them also. Just few observations. One thing is definitely you have to formulate your presentation. For example, one of a slide is on space science, spatio-temporal data. You had mentioned about approaches, graphical, statistical, MA. These are theoretical aspects. You don't have to mention that what is the technique, what are the various strengths and weakness of those techniques. It looks like a theory presentation in that case. You can be very specific rather than having so much. You can reduce the slides, reduce the content, but very much focus on which will be new for them to hear and keep the attention intact, because these type of texts matter, like definition or like various strengths and weakness of approach is not going to for them to have their interest on it. Second thing is that when you are mentioning about what are the work you are doing, I would suggest that just focus on what exactly you would like to contribute to them, or what you would like them to be partner with in terms of support of data or whatsoever, so that they know what exactly you are going to do with them and you want from them. So these two things from
Yes.
suggestions from my side. Otherwise, topic
Yes.
is only thing is formulation of the presentation in a better way.
Yes.
Right. So now, Rika, can you come to
Yes.
that last slide, last but one slide, leaving away the publications, where you have said that proposed area. We will actually start from there. I find some very interesting proposals. You can actually start defining the challenge from that slide. Like you have put spacecraft, the
Yes.
mission planning, spacecraft diagnostics, space weather monitoring. Just show it on full screen. Spacecraft diagnostics. Because how the anomaly, you first define the problem like this. In any space mission, the anomalies and abnormal events are challenges. These are the challenges because there are many unknowns which will come in the space mission. Just share the screen. So in this, you narrate some
Sir, is the
incidents.
screen visible?
No, it's not visible. Doesn't matter. What I want to, I give an example that you should first say that in this mission, such an anomaly happened, and then in that as a case study that they used this anomaly detection to rectify it so that they immediately the problem was attended to. So you can mention some NASA mission itself. If they have used a similar anomaly detection, the programs or the software, then you bring what is something unique in your approach in anomaly detection. So that first you have brought the importance of anomaly detection in space missions. Like it can be used for precise navigation for landing spot. Precise, you mentioned about that. Precise navigation landing spot you can identify using this.
Yes,
Or
sir.
if suddenly some challenges happens, anomaly detected. You can even change the trajectory if possible, or you give the autonomous function to that artificial intelligence to the system lander, that it will go and land in different place. So anomaly detection, how does it help in mission planning, spacecraft diagnostics if there is any problem while in flight or before takeoff, and the space weather monitoring? You have mentioned all this. So bring that. This anomaly detection has an application in space mission in these ways. Now, what you have done in anomaly detection, next you should bring, so that they know that anomaly detection is very important, which they know. Everybody will be knowing, because they will be handling this in their missions. So we normally use these data analytics and the algorithms. But now I have made a new algorithm, which was my PhD thesis, in which what is that new thing which you have brought in the algorithm? Bring that. Now, using this, I want to look at the space, our Indian space missions. Even if you can give some case studies where anomaly detection was used to rectify or in planning, mission planning, you can bring that if it is publications are available. Anomaly detections have been used in NASA mission, in this X mission, that they use this for this problem. So bring that. So similarly, ISRO also may be using it, will be using it. If there is an ISRO case study, bring that. So this is, first you bring the anomaly detection's importance, okay? Then the
Yes,
second,
sir.
you bring that some case studies where it has been used. Third is what you have done in this area, right from your PhD thesis and others, and publications. This is my strength. And my thing is differs from the conventional, if it is different. Or if it is a better tool, bring that. Then using this, I can do for ISRO this. This is how you should present your work. And sit with Prasad as well as Datta Saab input le lijiyega. And
Yes, sir.
otherwise, your work is important. Anomaly detection is very critical in the
Yes,
space
sir,
mission.
because sir, one of, sir, sorry to interrupt you, sir. One case study that we have done was of cyclone and the landslide that occurred in 2014 in Uttarakhand, and a cyclone in northeast. So we have studied that what were the metrics that were responsible for those events, and that we have studied through our algorithms that what particular scenario it was there due to which that event happened. So those were the anomalous events that has been identified through the proposed algorithm. So the
So
disaster
that
and the natural
you can
hazards,
delay
that
the
was
launch
also the
by
part
a
of our
day.
study.
If
Yes,
you
sir.
have detected it and forecast using your anomaly detection, a cloudburst is
Yes, sir.
going to happen in Sriharikota tomorrow, and tomorrow is the launch plan. So now postpone
Yes.
it by 2 days. Is it mission planning?
Yes.
So your anomaly detection helped in saving the whole mission by predicting this, using this anomaly detection, and then we delayed the missions so that the whole mission got successful, because 2 days later it took off successfully. So this is anomaly detection. So you bring
Yes, sir.
specific examples like this, where this helped the extreme conditions were detected using this, and this is you take a case study like what you mentioned. Yet like that in other the outside missions abroad, where such space missions were carried out, in which anomaly detection used to save the whole mission, or mission planning, or landing sites. All this, you can use it. Landing site, when the Gagannauts going to return back to India, where will the landing? Can you just change it? Because at that cyclone is predicted in that sea, over that area, over that region. So now landing site could be moved out. Like this is planning. So this is what is your power of this anomaly detection. But you should relate it precisely for this. When Gagannath, recovery of the Gagannauts back to Earth after return, there will be a site planned for landing in the sea. So now if there's going to be a high tide and waves and cyclone in that region, you will organize in such a way the landing is in a different place. So like this, you should show the relevance of your capability and then build a story on that. How you can do that, how your software or the algorithm is better, this anomaly detection algorithm. So that is how you should tell the story. Okay, good, very good. Now,
Yes, sir.
Shefali,
Thank
I
you so
will,
much.
Sir.
I think I will be coming there, and so we will sit together today, who are all
Yes, sir.
people to do. And also the brochures have to be finalized. And
Yes,
so
sir.
you can call Shefali, Suchendra, and we should go there for their inputs also. So the draft we can just approve.
Yeah.
So I'm coming there if Singh Saab and Neeraj Sharma and
Yes, sir.
Khatri is there.
They have also requested your presence immediately
So
after the meeting, sir.
yeah, so that these three items are important priority for us. And then I will brief also what I have spoken to C5, C6
Yes, sir.
for the
Yes, sir.
other logistics and their participation and
Sir.
all.
Sure, sir.
Thank you, Dr. Rika, and thank you, Dr. Amir.
Thank you so
And
much, sir. Thank you so much.
very
Yeah,
great
thank you
work
so much,
you
Dr.
are
Rika.
doing.
All the best to you.
It gives me an opportunity
Thank
to
you.
understand all that what is the great strengths available in Amity Group in every area, including space science and technology. Abul, great work. Rika, blessings to you. All the best.
Thank you, sir.
Thank you so much.
Thank you, Prasad. Prasad, guide them. Datta, both of you, data analytics and AI, you people kindly guide them. Bring the relevance to ISRO. ISRO people should like, oh, this is the project I want.
I will
Good.
be,
Thank you.
we are
Thank you.
working on that.
Thank you.
Thank you so much, sir. Thank you, everyone.
Thank you.